Today's problem is to find the maximum path sum in a binary tree, and it's problem number 124 of LeetCode. And we will see a solution in C++, Java, and Python. So first, let's understand the problem. So you are given a binary tree. This is a binary tree. You can see some negative nodes, some positive nodes. So positive, negative, both are allowed. And you have to find a path, and a path is a continuous path. You cannot have 2, 15, 27. So this is one path, and you also include this. That kind of path is not allowed, like this one. So this will become a generic tree, not a path. So path should be like this. It can be a straight line, it can be one node, but not like this. So in this case, the longest path is this one. Not longest, but the path with the maximum sum. So let's see how we can find that. So if you remember the question on that finding the diameter of a binary tree, and there we were finding what is the longest. There the notion of longest means the number of nodes on that path, and that we call the diameter of tree. Here the notion has slightly changed. Instead of counting just the nodes, we will count their values. Here the count does not matter. The sum of their values on the path matters. So you can see some similarity here. Although that problem has been labeled as easy, this has been labeled as hard. But I see that the concepts are very similar. So there are three possibilities. Just like this diameter calculation, we had considered three scenarios. Here also three scenarios are possible. What are those scenarios? So this is root, this is left subtree, this is right subtree. So first scenario is that longest path lies completely in left subtree, or let's call it T1, T2. Second scenario is that longest sum path lies completely in T2. Third scenario is that it passes through root. These are the only three scenarios, and you have to include at least one node. So either that node will lie in left, right, or we have a longer path. So these are the three scenarios. Root included. In first two cases, root is not included. So you can naturally see a recursion happening here. When we are calling maximum path sum, let's call it MPS on root, we need to check just in this left subtree, excluding everything, even root. So what is the maximum of MPS in left subtree? And we need to also check a case where what is the maximum sum path in the right subtree, and what is the third case, that path goes through root. In these two cases, we are just checking in this part, and root is not included. In the third case, root is included. So while calling it recursively for left and right subtree, we don't need to just keep track of what is the value returned for the maximum path sum. We also need to keep track of one more thing, just like this diameter case. There we kept track of what is the deepest path, including the root. Here we will keep track of what is the maximum path sum. So when we are traversing left, we have added this value. And when we go on, we keep track of what is the maximum path sum that I can get, including the root. So it will be a straight path. So the case where root is included, this left part should be straight. It should not have any branch, because that will violate the definition of path. So we are just considering the third case. These two cases are clear. So this should be straight path. This should be straight path. It can be like this. So from here you can go left or right, but not both. So no branches. These are all continuous straight lines. So we need to keep track of such kind of linear paths. in the left part and right pass. So we will pass one additional variable by reference. Let's call it h. Call it h1, then h2. And here we have to include at least one node. So now once these two values return, let's say this MPS left returns D1, MPS right returns D2, and the maximum length path including root in left subtree has a value of h1, and in right subtree it's h2. Now what? Now we keep track of we need to keep track of what is the h. So this is h1, root included, and this is h2, and d1 will be the path length in this part, and d2 will be the path length in this part excluding the root. So when the call returns from this value, maybe this was called from some node above, so we need to update the h for this, that is including this node, what is the deepest most valuable path you can get. So there are a few scenarios. So let's say we are considering for this node, this is left subtree, this is right subtree. Let's say this h1 is negative. Let's exclude the value of this root for now. So whatever is the straight path, this is negative, this is also negative. So will you add h1, h2 and this root value, or will you just add the root value? So let's say h2 is positive. Then we know that if we add this root value and this h2, then we will get some better h. So initially h was this, whatever is the value of root. We have to anyhow include this root value because we want to find a straight path including this node. So its value is included, let's say v. Now you will think that which side I should take. I cannot choose both sides. I am just finding this one-sided h. So either left or right. Which side? I will pick the max, whichever is greater. Let's say h2 is greater than h1. Then will we simply add v plus h2? No. If h2 is less, let's say less than 0, then adding it to this does not improve our height. So we will not include it. So first we will pick the maximum of h1 and h2, and whichever is larger, we will check if it's larger than 0, then we will add it to root value, and that will be the h for this case. So h will be max of h1, h2 or 0. So maybe both are negative, then we will pick 0, and we have to mandatory add the root dot value. So this will be the h for this node for which we have calculating MPS after left and right calculations are done. And finally, what will be the return value for this node? It will be the maximum of D1, this first case, or D2, the second case. And the third case will be that it goes from root. So it goes through root, so we have to include val plus, if in third case we will take this h, h1, and this h, which is h2. So if this is included, we have taken it. Now we will include h1 if h1 is more than 0. So h1 or 0, max of this, plus max of h2, 0. So we have taken the three cases, first case, second case, third case, where root is mandatory and these h1, h2 are optional depending on whether they are greater than 0 or not. If both are greater than 0, very good. We will take this part also, and the root. We will get this path. And we will compare which is maximum among these three. So I hope it's clear. Now we will start implementing it first in C++. Then I will modify it for Java and Python. So this is the h that we are keeping track of, and we will pass it by reference. Let's define a helper function, mpsum, and why we are returning int min instead of usual 0, because if we are taking for a current node and left part is completely negative, uh, so ultimately at the leaf node it will call for its left, and it will be null, so it will return 0. So we will pick which is maximum, the current node or the left part. So we will always pick 0 in that case, but that is not the case. We have to pick at least one node, even if everything is negative. So that's why this int min is required. Otherwise, if we pick 0, it will work for positive cases. But if the answer is negative, then it will fail. And then h1 equal to 0, or int min here. So remember this logic here. The h for current node will be either, so this node we include, then we see the max of h1 or h2 or 0. Max of d1, d2. And let's try it. It works for this simple case. Let's take this case. So it's also giving a preview of the tree. This was not earlier. This I think is a new feature. If you write the nodes, it will draw the tree also. So this is pretty useful for defining your custom use cases. And it works. So in this case, it's 42. And let's try one negative case. So -1, -2, -3, same as this. So here it should be -1. This is the largest. We have to include at least one node. And it works. So let's go ahead and submit. And the solution in C++ is accepted. And now we will write it in Java. So I will copy this part. And here, in order to pass it by value, we cannot pass int. It will be passed by value, not reference. So we need to pass by reference. So we will be using atomic integer. Uh, and here also we will pass atomic integer. H1 H2 will not compare. We will need to get its value. And then and let's try if it works. And our answer matches. So let's submit. And the solution is accepted in Java as well. So finally, we will do it in Python 3. Uh, so here, passing by reference would be setting a variable in self itself. We will call it mpsum. If root is none, if root is null, we return this. Let me copy. Before calling it, we will set self.h equal to minus math.inf, and once it returns, this h will be updated and we will store it in a variable h1. Similarly, and then h will be max of h1 is 2, 0 plus root.val, and here it will be let's see, and it works. So let's go ahead and submit. 1, 2, 3 output is 3. Okay, so here it was a mismatch. Let us see. This is fine. Root is null. We return this self.h. h1 equal to self.h. Okay, we are not setting h. This h is not used. It should be self.h. And this time it's correct. So hopefully it should accept the solution. So it accepts the solution in Python as well. So hope you understood this problem. The main thing was that there can be 3 possibilities. The maximum path sum lies completely in left subtree or completely in right subtree. In both cases, root is not included. In third case, it passes through the root, and there also it can be multiple scenarios. It includes the root, that is mandatory. It can include optionally left or right part. So just go through it and it should be clear.